Hello friend, welcome to the channel Pharmacy Dictionary. In today's lecture video, we are going to study about agonist and antagonist, their basic definition and the comparison between competitive and non-competitive antagonists with respective diagrams. I am so sure that this video will going to help you in all kind of examination and this will clear your all kind of doubts. So please be with us, stay till the last of this video if you want to grasp the knowledge very deeply. So let's start presentation. Here I have used or draw 4 diagrams. In this diagram I have not included any of the animation because it is very important for you to compare each diagram with the respective all diagrams. Image number 1 is representing the resting state. Image number 2 is for the site of action for agonist when agonist took place on the site of binding, and the third one is for the partial agonist, and the last one is for competitive antagonist as well as the normal blockers too. So each and every diagram is a full node by itself. In the first diagram, that is image number 1, is representing for the site of action for agonist and antagonist. This is a representative diagram. Neither agonist nor antagonist has yet took place in his binding site. So this will show you what are the basic place, what are the basic sites, and what are the basic types of drug according to their chemical or physical nature. In this diagram, as you can see, this is a agonist. A circle of orange color is representing agonist. And now what is the meaning of agonist? Agonists are those drugs which facilitate the activity of any signal molecule, or we can say just they are the drug or they are the agent which mimic the natural signal or ligand molecule. And what is the receptor? Receptor here, as you can see in the diagram, receptor are the macromolecule, not micro, it is a macro. It is a macromolecule which are available either on the surface of cell or inside the cell. They do not have any pharmacological or biological activity. They used to just recognize or identify the agonist molecule or signal molecule or ligand molecule, so that they will allow their combination and they will form a drug plus receptor is equal to drug receptor complex. Whenever there is a formation of drug and receptor complex, then only we may achieve the pharmacological or biological response. If the drug is alone or if the binding site, that means receptor, is unoccupied, there will be no such activity and that will be of no use for us. So this is very important to bind agonist or any drug to take place in the binding site, then only we will have any kind of desirable effect in this case. So this is the first diagram just to explain you the basic parts of any drug receptor complex. Now let's move to the image number 2. You should do one thing, you should compare image number 1 with the image number 2. Now, what is the basic difference between these two images? In image number 1, neither agonist nor competitive antagonist nor receptor has been occupied with themselves. But in this image number 2, as you can see, agonists come little bit downside and it took place in the binding site. So there is a formation of drug plus receptor, that is drug receptor complex. That is why there is a response is going on. So if you want to take any response, the drug should be bind in respective binding site. So this is called agonist. Now we have to understand the definition of agonist. So here is the definition of agonist. Agonists are the agent which activate the receptor and produce the effect similar to the of physiological signal molecule. Here agonist took place, that means activate the receptor, and this activation result in the functional activity or physiological activity as like physiological signal molecule. Now let's move to the image number 3. Image number 3 is representing the partial agonist. What is the meaning of partial agonist? See, you have to remember one thing. If someone is asking about the agonist, that means they are talking about full agonist. But most of the case it is not written as a full. So if it's written as an agonist, you should consider it as a full agonist. But now in this image number 3, there is a highlighting word emphasizing this word. That's called partial. What is the meaning of partial? Partial means half, not full, less than full. It's called partial. So if there is an agonist that will facilitate the binding site, that will activate the receptor to produce the effect similar to the physiological signal molecule, but you should focus on this word, that is partial. So it will activate but the activation will not be result into 100% response as compared to the full agonist. So you will have response, but the response will be not 100% as in case of agonist. Let me explain you with the help of diagram. So if just imagine, it is not happening right now, but just imagine if this agonist will occupy by this receptor, there will be a formation of drug receptor complex and that will produce its maximal response, or we can say maximum response. Both are correct. But in this diagram, the partial agonist is coming towards the receptor or binding site and occupied this space. So the receptor binding site is full. Now it will produce action, but this action will not be equilibrium or equal to the full agonist. But then what will be happen? A response will be obtained. The biological response will be produced by this. But it is also acting as an antagonist for full agonist. You should understand this point very carefully because this will cause confusion. If full agonist occupied, they will produce full effect, but partial agonist take place in the place of agonist. So it is not allowing agonist to take part, and the full agonist is not taking part. The action or response or biological response will not be 100% yet. Have you got the point? Let me give you a simple example. If you and your son traveling in a bus and you will take a half ticket, either bus or train, both are applicable. You will take half ticket for the child because he is not adult, and you will have to pay full amount. But the seat is being occupied by your child in half amount. So it is not allowing the owner of bus or government who is taking charge of your fare, he will not get full fare. Although you are occupying full seat, but full fare will not be given to him. That is the basic difference between full agonist and partial agonist. And what is the definition of this partial agonist? Let's go through the next text. This is partial agonist, an agent who activate the receptor. It is activating because drug is taking part or taking place inside the binding site. But they will not produce a maximal response. They will produce submaximal response, and they will also antagonize the effect of full agonist because now they are not allowing, focus on this line, they are not allowing the full agonist to participate in the reaction. That is called partial agonist. Now we have to understand the meaning of antagonist. So let's consider image number 4, competitive and non-competitive antagonists. Agonists are allowing the receptor activation in a similar way, but antagonists are those agents. Let me clear you the definition first. Antagonists are those agents which prevent the action of agonist, and that means they will not allow the action of agonist on a receptor side, and they will not produce their any own effect. So just they are using to inhibit the action of agonist. So in this case, suppose agonist is coming and agonist will take part in this receptor binding site, but there are antagonists. Two types of antagonists. First is competitive antagonist and the second one is simply a blocker, we can say. So in this diagram, agonist is in orange color, but antagonist is in green color. So in this case, this green color competitive antagonist will compete with this agonist, and they will fight for the same binding site. Whoever is more powerful will occupy this binding site. So there is a competition between these two, competition between agonist and antagonist. That is why it is named as a competitive antagonist, and its definition is written in this box. So this is called competitive antagonist. And there is another type of antagonist that is non-competitive. If the antagonist will occupy in another part of the receptor, not on the same receptor, they will not fight with the same, and that can affect the binding of agonist in its own binding site. That is considered as a non-competitive antagonist. So there are two important terms, competitive antagonist and the non-competitive antagonist. So let's start the differentiation between competitive and non-competitive antagonist. Here in this table, I just tried to make you clear the concept. So first, at your left side, there is a competitive antagonist, that is also known as an equilibrium type, and the right side, this is a non-competitive antagonist. So difference number 1, antagonist binds with the same receptor as the agonist. As you saw in the image, the both agonist and antagonist are fighting for the same binding site. Let's go back again. Here in this image, there is a binding site is single, but both agonist and antagonist are fighting to achieve the same binding site. So this is called competitive antagonist. And in case of non-competitive antagonist, binds to the another site of receptor, not for the same site. Second differentiation is antagonists resemble agonists chemically. As you have also seen in the previous image, antagonists and agonists are looking like same, but the color was different. That means they are chemically same. These are called competitive antagonists. But in case of non-competitive, these two are not resembles each other. Next differentiation, parallel rightward shifted of agonist DRC. If antagonist will antagonize the action of agonist, the DRC will shift it toward the right side. But in the case of non-competitive, it will be completely a flattering pattern of agonist in DRC. That's called drug response curve. But in case of competitive antagonist, the next differentiation says the same maximal response can be attained by increasing the dose of agonist. If you want to antagonize the action of antagonist itself, then you have to increase the concentration of agonist so that the agonist will again compete with the antagonist, and because of its strength is increased, it will replace the antagonist again. So this is all about the concentration, all about the increasing dose of the particular drug in case agonist or in case of antagonist both. So but in case of non-competitive, maximal response is suppressed. We cannot interchange. Next differentiation, intensity of response depends upon the concentration of both agonist and antagonist. As I have explained you the earlier, the both intensity of agonist and antagonist can be nullified by each other if you increase the concentration of one in the respect of another. But in case of non-competitive, maximal response depends only on the concentration of antagonist. There is no value of concentration of agonist at all. But the last, it is the example of competitive antagonist is acetylcholine. This acetylcholine can be antagonized by the atropine, and the effect of morphine can be antagonized by the naloxone, as I have explained you in our main channel Solution Pharmacy. And the example of non-competitive antagonist is diazepam, which will be inhibited by bicuculline. This will antagonize each other. So friend, this was a simple yet very important video regarding agonist and antagonist, along with a comparison table between competitive and non-competitive antagonists. Hope this video will clear your basic doubt. If you have any kind of doubt, feel free to ask me in comment box. Thank you again. Please do take care of yourself.